Okay, I want to talk to you about Dalton's atomic theory. There are 4 parts to Dalton's atomic theory that you're going to have to know. These are just statements about the atom up to this time. John Dalton, he's an English teacher, which is kind of weird. But he took he's a Renaissance guy. He was, heavy into science and the physical sciences, and he looked at information they had about matter. And he came up with 4 statements that we still look at today as a pretty basic ideas about the atom and theory about the atom. Okay, first thing is on number 1 is that it's a real easy concept to understand. All matter is made up of indivisible particles called atoms. These atoms are the smallest part. You can't break it down any further. If you do, you no longer have what we consider characteristics of that particular element. So it all kind of came about from a long time ago when the word atomos was defined, and it was defined as indivisible. So that's kind of where they got the word from the Greek word atomos, which is indivisible. That's how they came up with atom. Second one, he stated that all atoms of a particular element are identical to one another. Which means, like, if you have a sample of a bunch of atoms, it just makes sense that if you break it down to the smallest atom, that smallest atom will have properties of a bunch of atoms that are together in a sample. So he just says, you know what, they all have identical properties, whether it's mass, shape, size, physical properties, chemical properties, they're all the same. Okay, so that would have been the first 2. Number 3 is where we have atoms of different elements. What they're going to do when they combine to form compounds, because we know atoms in themselves don't make all substances up, but also compounds, and compounds are made up of atoms chemically bonded together. We know when they bond together, they're always going to go together in definite whole number ratios for any specific compound. So we have written H2O. Every time you have a molecule of H2O to go together to form a compound, you have to have 2 hydrogens for every oxygen. That never changes. CO2 would be something similar to that, so that for every 1 carbon atom, you have 2 oxygen atoms that need to hook on, and it gives you properties of carbon dioxide. H2O can go together to form different types of compounds as well, so it doesn't have to be an exact ratio only. It can be multiple ratios, but they're still going to be whole numbers for that particular compound that have specific properties. And the last one we would take a look at is, we all know that we have chemical reactions and we end up with different products. So what he's saying is that atoms, basically, to form new products, will, if the situation's right, they will react. And when they react, they'll if they're in a compound, they'll separate. They'll rearrange themselves with another reactant, and then they'll form a new product and combine. And that's a simple concept that atoms will do that. Now, the thing is, they don't lose any atoms in the process, so because of that, they're going to keep their mass consistently the same before and after the reaction. So that's called the law of conservation of mass when that happens. All right. So that's 1 through 4. You're going to need to know that. We'll review that again. But going back through this, all matter is made up of indivisible particles called atoms. The second one, we're going to say all atoms of the same element are identical and they're different from other elements. The third one, we know they're going to combine in whole number ratios. and specific definite whole number ratios depending upon what compound you're looking at. And that when we have reactions, they're just going to rearrange themselves into a different setup to where we're going to have different products. Okay, so next thing we're going to take a look at in this process is there's a gentleman named J.J. Thomson. And he discovered electrons. And how he did it is he had a cathode ray tube. And cathode ray tubes in your book, and you want to see an example of it, you can turn to page 112. And on 112, you can see there's an example of a cathode ray tube. And on one side, it's going to have a negative post, and on the other side, it's going to be sent through a positive and negative field. If you notice in your book, it's attracted toward the positive field, and it's, forced away from the negative field, which both of them are showing that the atom is negatively charged. So he used all different types of metals, and it didn't matter what metal he used. This particle that was coming out of this metal, that was part of the metal originally, was negatively charged. So he discovered the electron. And they found out that when they deflected it, it didn't have a whole lot of mass compared to the mass of where it was coming from. So that just showed it had a very small emphasis of mass within the atom. And because of that, we know matter, for the most part, is neutrally charged. That if matter has a bunch of these electrons that are negatively charged, something has to counteract that, that's positively charged. And so it indirectly discovered the proton. Now, didn't know where the proton was at, didn't know where the electrons were at, but they knew that there was a particle within the atom that was electrically charged, that was a negative charge. And they also knew that because of this, protons were, well, later on they were called protons, but they knew there was something positive in the setup. Okay? So that's Johnson's, or J.J. Thomson's cathode ray tube experiment. So, this picture in your books and on page 114 is a little bit different than the one I have drawn here. So if you look at this drawing, Rutherford Goldfall experiment was an experiment that took the lead, that little C, it looks like a C to the left, was a lead box. Inside that lead box they had a radioactive material. They gave off radioactive particles, and they're called alpha particles. Those alpha particles were directed toward a piece of gold foil. Later on it was found to be 10,000 atoms thick. So as the particles went through, as you can see to the right, 99.9% or a very, very high percentage, the pathway was not deflected at all. Okay, so if you look on page 14, you can see that it's showing some deflected particles and the reason why. Better than my drawing here. But anyway, they went straight through. But every once in a while there would be one that would kick backwards, like the one on the left that angles down, or the one on right after it went through the gold foil that it was deflected not toward the center anymore. So, knowing that information, they were able to take the data and look at it and try to figure out something about material that's mattered. And what they figured out and came up with is that since most of the particles went straight through, that an atom is mostly empty space. But every once in a while, very rarely, there was a deflection. And that had to be caused by something that was really dense, because this alpha particle was pretty heavy and it was moving at an extreme fast rate of speed. And something to deflect it had to be something that was pretty dense. And because it was being deflected, a positive particle, that in itself it was positive as well. So there's where the protons were discovered, based upon Thomson's experiment saying, hey, you need to look for something that's positive, and they did. But this nucleus was very small because of the very few deflections taking place. Because it had all the mass of the atom, which we now know it has protons and neutrons, it has a very high density. And they found out later that these protons did not make all the mass of the atom up, so there had to be something else. And that something else they found out was neutrons. And the neutrons are kind of present to kind of hold and stabilize the atom together. Because if you know protons get together, they don't want to stay together because they're all positively charged. So what we have is Dalton's atomic theory. We have J.J. Thomson's cathode ray tube experiment and the results of that. And then Rutherford's gold foil experiment and the results for that. So these are on pages 112 through 114. You can read through those to get yet a better idea what's going on.